My name is Alanus von Radecki. Thanks for the nice introduction. I work for the Fraunhofer Society, which happens to be Europe's largest organization for applied research. Most of you, I guess, are familiar with us. We have initiated an initiative a couple of years back, which is called the City of the Future, Morgenstadt in German. And it's about creating innovations and applying innovations and piloting innovations to create more livable, more sustainable, more efficient cities and urban environments. And today I'd like to speak a little bit about this work and some of the outcomes. It's about applications, it's about technologies, but it's more even about the question how to create a new and very complex market at the interface of the public and the private sector. Technologies have the opportunity to change the way our cities work and look like. This is an image of New York City, Fifth Avenue in the year 1905. This is how cities looked like in 1905. And if you fast forward 8 years, this is what happened. It's the same street in 1913, Fifth Avenue. What happened? Between 1905 and 1913, a new technology was invented, was produced in mass, and was brought into a market, and it radically changed the way how cities work and operate. A key consequence of this is, of course, that people were not, it wasn't necessary anymore for people to live close to where they work. They were not dependent anymore of walking or taking the tram. They could drive. And that's basically what happened with our cities, right? We were able to spread out and to sprawl. Now, we look upon cities from the perspective of sustainability. And there are some very ambitious goals around climate change mitigation and resource efficiency on European level, but also on a global level, if we look for the Sustainable Development Goals. And having cities develop and spread as an unintended consequence of a new technology is something that we cannot afford in the future. So our question that we follow is how can we design technologies in sort of co-creation of what is to become a sustainable city? If we think about another technology, so this is nothing new, but it's a bit more recent. 2007, the iPhone was invented. It's only like 11 years ago, right? All of you, I guess, know this picture, right? What happens in our cities when a new technology gets introduced. So this is 100 years later. You see our city in 2005 and our city in 2013. A new technology has been introduced. Everyone is using it. What that is doing to our cities is still to be figured out. But honestly speaking, I wouldn't be able to find my way around in cities totally strange to me if I didn't have my smartphone and Google Maps and all the nice applications that help me find my way around. So it has dramatically shifted the way how we move in cities, and we've seen it also how we plan cities and how we build and operate cities. So there is a huge potential within digital and connected technologies to build sustainable, more efficient, more livable cities. And I'd like to just highlight a couple of points, a couple of applications and potential technologies which we are seeing to emerge in our cities. One, of course, is the autonomous car. Everyone is talking about the autonomous car, and everyone is sure as soon as we've got 5G networks in our cities, autonomous cars will be dominating the way how we move in our cities. And it is definitely something that we should consider very closely and that we think will happen in the future. Just imagine a system where 90 to 95% of the vehicles are shared, electric, connected, and autonomous, right? You don't need to possess it. You can just enter a car, order a car on your app, enter the car, let yourself be driven wherever you want to go, get out of the car, and the car goes and picks up the next customer. So this has a potential gain for cities, which goes into the billions per city. We did the math. For the city of Stuttgart, there's a potential added value of a fully electric, autonomous, and shared mobility system of about 4.5 billion euros per year in reduced emissions, in reduced congestion, in freed up public space, in the lack of parking spaces that you will not need, and so on. But our perspective within the Fraunhofer Future Cities initiative is about the entire system. And so we need to look beyond the mere technology and its potential, but also how do people interact with this? So what would happen when, you know, this system would spring up? I think one of the first things would be that you know, stressed out family fathers would tell their kids, oh, just order that car and get yourself to school, because it's really easy, right? And so by just looking at the technology system, the technological system, we would run into the problem of doubling or tripling the traffic on the roads, which is not what we want, even if it's electric vehicles. So what we're seeing at the moment, and where we are closely interacting with cities and municipalities, is to design an entire mobility system around shared, connected electric mobility. And it's interesting that it's not the large OEMs, it's not the Mercedes and BMW that are bringing these sort of shared vehicles into cities. It's the startups, it's the players that we wouldn't have expected there. It's like the Deutsche Bahn that are experimenting with people movers that are autonomous, that can be shared, and that are closing the interface between the public and the private mobility system. Another example is the entire system of energy creation or energy production and energy demand in cities. There is a new regulation coming out that I think by 2018 or 2019, all new public houses in Europe need to be near zero energy. And by 2021, all new privately owned houses need to be near zero energy houses. And we have the technologies that will enable us to create plus energy houses already today. This is an example from the city of Stuttgart, from the architect Werner Sobeck. It's the plus energy house, which is connecting different sources of energy production, so photovoltaics, solar thermal energy, geothermal energy, to storage systems, like, for example, an electric vehicle, and to a smart building energy management system that enhances the efficiency of the entire system. If we expand this system to the district, we are actually able to create positive energy districts. And that is based on connectivity and connected energy technologies. There is a project we are running in the city of Amsterdam where the stadium it has a specific energy demand with the high energy load for the floodlights every second week, or sometimes every week. And when Ajax Amsterdam is not playing, there's this, well, they don't have a specific energy demand. So this is a very good system that you can use, excuse me, that you can use to build up a district storage system, a lithium-ion battery, that reduces the costs when energy costs are high for the floodlight system, but that enables you to offer a storage system to your district when you don't need it for the stadium. So imagine a district or future city districts where we have photovoltaic on the different rooftops, where we have a district storage system, and where we have, for example, a blockchain or whatever other intelligent ICT system that connects consumers and producers of energy to that system. I can rent out a rooftop in the district to install a photovoltaic system. I can rent some space in the district storage battery and then decide, will I consume this energy for myself when it's most convenient for me, or will I sell it to the energy spot market when it's most expensive? So these are the smart systems that we are talking about when we talk about smart cities. But here again, you can use and design this system to increase revenues for the owners of the system, or you can design it in a way that you create secure, clean energy supply for an entire district at affordable costs. So again, here the question is, how do we design these systems? Just a couple of additional sort of technologies and innovations that have an impact on our cities. Big data, right, and online shopping has a much higher impact on the way how our cities are running than we might suspect. So up to 60% of the traditional shops are about to disappear through online shopping. This is not a new information. But through big data analytics, we are able to not only, replace these shops, but large companies like Amazon are actually able to be better than those shops because they know exactly when you will be clicking on the buy button. They can send the stuff towards you even before you've bought it, because there's so much data available about consumer behavior that you're able to predict in a very accurate way when you or maybe your neighbor or the one next to your neighbor is going to purchase a specific product. What does that do to our cities? It increases the demand for logistics, of course. So in our city centers, you've all seen this, we have still these very large brown or blue or yellow trucks running around delivering parcels to everyone. Now this is something that cities aren't very happy with, and so we are experimenting a lot with alternative logistic concepts in cities. So this is one startup, Starship Robotics, that is piloting a autonomous parcel delivery pod in Hamburg. But there's the other drone-based delivery systems. There's e-bike-based delivery systems, and the key challenge is to aggregate and consolidate basically the deliveries and manage the supply. All of the data that we develop and create in cities need to be coming from somewhere. They need to be they need to be brought out of the city somewhere, and the street lighting is what is to become the backbone of the smart city, because we are able to deliver connectivity to the entire city via an existing infrastructure, which is the street lights. So, as an example from the city of Eindhoven, we have developed an entire district, Strijp S, the former Philips industrial park, into a fully connected urban infrastructure. Basically, in each street light, you will find a fiber optic cable. And this is definitely something that we will be seeing much more in the future, not necessarily in every street light, but connectivity of our data-generating sensors and assets in our cities is happening through urban street lighting. And then we need a place to store and to manage and to operate these data, and ideally, in the future, come to evidence-based decision-making in our cities. So this is something where we are not yet, but it's definitely something that cities are looking into and cities are working on. So last year, in December 2017, we've developed the first standard for an open and interoperable urban data platform. It is basically a standard to avoid vendor lock-in, to avoid the growth of many different non-interoperable platforms and data standards. And now cities, whether they work with Cisco, whether they work with Siemens, whether they work with Bosch, SAP, or whatever, can be sure that there's a joint standard for an open data platform which they can apply in their city, and which makes sure that whatever system they use in the different areas, be it the energy, be it the mobility, be it health or weather monitoring, are interoperable. So these are just some examples of where cities are standing at the moment when it comes to smart city applications and technologies. But why are we not seeing that everywhere? Why isn't each city already, operating or piloting electric and autonomous vehicles? The technology is there, right? It's not a question of inventing something new. So there's a couple of challenges that we are seeing that are making this pretty hard to scale and to mainstream. And I'll just name 2 or 3 of those challenges to help understand what is the type of thing that we need to overcome and where we need to work. So this is from a study that we did in 2017. We basically analyzed something like 186 technologies specifically designed for cities across the life cycle. So you'd see here the blue dot at the very left side is maybe the first horse-carried tram system in a city in 750. And across the last, say, 250 years, we analyzed the innovation cycles of these technologies. And you can see, so each dot is a technology, and you see a logarithmic scale on the x-axis. And it basically shows how long does it take until one technology, one urban technology, is being replaced through another technology, which is delivering the same service in a better, more efficient way. And what you can see is that basically the innovation cycles throughout the 18th, the 19th, even the 20th centuries were beyond the time horizon of 10 to 15 years, which happens to be the time horizon that we need to do urban planning, to do the development of a new district, right? Large infrastructure projects, etc. But since the year 2000, more or less, when digitalization started to kick in, we can see that the innovation cycles for specifically urban technologies are dramatically increasing. So they are shortening, right? And that means that our traditional ways of planning and building cities are just not able to keep up with the speed of innovation. Think about, I'm from the city of Stuttgart. There's this famous Stuttgart 21 project that was planned in the 1990s, right? There was no BIM in 1990s. There was not even a smartphone. There was nothing like this in the 1990s. It's being built now based on the plans that were designed in the 1990s. They have been modified, they have been improved, but the basic plans are from the 90s. Or think about electric vehicle charging in cities, right? We are at this moment starting to discuss about more or less, mainstreaming electromobility in our cities at a certain point. There are cities like Stavanger in Norway where already 25% of the vehicles are electric vehicles, but this is really an exemption. So we're just starting to discuss about e-mobility, and we're happy to see the first cities building up charging infrastructures, stationary charging infrastructures. At the same time, we are having the other discussion about autonomous vehicles. Now, if we bring that together, it's more or less evident that autonomous vehicles will not be able to charge themselves on a manual charging station, right? They don't have an arm. So you will need a different system for that. You will need an inductive charging station that is able to cope with the technology of an autonomous car. So here, this just gives an example of, even though this is not an innovation cycle of 2 years, it's maybe an innovation cycle of 5 to 10 years, how we are unable to embed these technological developments in our urban development plans. Another point is the issue of interconnectivity. So when we are talking about smart city technologies and the solutions, the examples I just made you, we're talking about interconnected assets. So this is an example from the city of Stuttgart, but you can find it in many other cities, where you have an electric car sharing system. In order for that system to be operational, you need a lot of different building blocks and pieces coming together, right? One key innovation is the electric drivetrain and the battery in the car, but then you need all of the system around it. You need the charging infrastructure to be built up. You need the plug that needs to have a specific standard so that every car is actually able to use it. You need to provide renewable energy to that system, because otherwise, why have an electric vehicle system? You need a booking system, you need a billing system, you need somehow to access the charging station, either by a card or by an app. You even need a regulatory innovation, because usually in our German law, you're not allowed to park your car on a public parking lot in a proprietary way. So you need to adopt the actual regulation. So this interconnected way of creating new systems for our cities is tremendously complex, and it increases transaction costs, right? Because you have a lot of different stakeholders involved, and all of them need to collaborate. And if one of them is feeling that somehow that idea doesn't work out for him or her, he will draw out. And there's another challenge that we are witnessing when it comes to smart cities, and that is more and more connected to the very nature of the data economy. So today, we are dealing with a system that is built on basically zero marginal costs, right? And through this, data has a very, very different nature than any other product. So for data, for let's say a digital service that I provide to a city or to citizens, it doesn't matter if I provide that service to 100 people or to 100,000 people or to 100 million people, right? I can just copy it and provide it to everyone via an app. That means the way how we generate value in cities is changed in a completely different way. And we have difficulties of grasping this, right? What that means. Think about Uber, right? This is exactly the model that we are talking about when we talk about digital services for cities. You have a platform. You have user-generated data. Your users generate the data from you. You put some smart and automated algorithms on top of it, maybe based on artificial intelligence. And then you give a service, a digital service back to your customers. So Uber had a value of something like, I don't know, $2 to $10 billion, having only 40 employees. Only 40, just think about this. So the way how we create value in our cities is changing dramatically, and we need to understand the data economy in order to be able to understand how we deliver value to our city. Because delivering value to a city is something much more complex than just delivering one digital service, right? A city is also about jobs, about a local economy, about education, health, well-being. So we need to understand the entire system and how the data economy is impacting the local economy in order to understand how do we generate value with a smart city. So summing this up, basically, we need to develop a new operational system to manage the digital transformation in our cities. And also we need to create a joint effort to create an open, interoperable, but rule-based market for smart city solutions in Europe. And let me just use the remaining 10 minutes or so to give you a glance of some of the work that is being done on that level. So within Europe, there is a huge initiative many of you know. May I just ask who of you is familiar with the Smart Cities and Communities Lighthouse Initiative by the European Commission? Anyone? 1, 2. Okay, that's not so much. So let me explain it very, very briefly. The European Commission has channeled significant investments into the development of smart cities by initiating pilot projects around Europe. So here you see 57 cities that have won tenders, well, not tenders, but calls for innovation and demonstration projects around smart cities. The European Commission has channeled 500 million euros into those demonstrators, and we are, as Fraunhofer and with our Morgenstadt partnership, we're taking part, so overall it's 12 projects, we are actively taking part in half of them, in 6 of them. There is 530 specific technological interventions, like the ones I just showed you, around car sharing, bike sharing, smart lighting, building energy management systems, smart districts, sensor networks, etc. But the question is, how do you get from those 530 individual interventions that are funded mainly by public subsidies to a joint market? So what we are working on at the moment is something that you could maybe compare to the principle of Lego, right? So if you think about Lego, you just need to choose your platform, right? Do you work with Lego or do you work with Duplo or another platform? And then you have thousands of different but standardized building blocks to create your individual project or your individual solution or house or whatever you want to build. And you can purchase pre-configured kits that help you build a specific Lego set, right? So the asset, the advantage of this is that this builds trust and confidentiality. It also increases it helps you speed up the decision-making process, and it's interoperable. So you're actually able to anticipate what you get in your city if you use the Lego principle. So what we are starting to do now is we are working across these 12 projects, these 60 plus cities, these 530 interventions to build so-called packaged solutions, where you need to relate the societal need in a city to the local context, to the technological options, and to the business models and the finance. And if you're able to package this in a coherent way for a set of solutions that you need for your smart city, then you are actually able to mainstream and scale up the smart city across Europe. So as an outcome, we have designed a platform, an open marketplace for packaged solutions, where you will find this, right? You will find packaged solutions on a lot of urban interventions and smart city solutions. You will find the use cases for those. You will, they build on a functional taxonomy. I'll explain that in a second. There are some technological options and standards, and also the business models and the financing options that you need to do this. The cities can use it to create and develop their own projects and to run tenders, because developing tenders is usually nothing that is prone to innovation. The companies can use it to attach their own products and services to these solutions. And bringing this together is actually speeding up the market. Now, what do we mean with a functional taxonomy? So the functional taxonomy is something that doesn't ask in the first place, what is the technology behind the solution? In the first place, it asks, what is the job it gets done for my city? So if you think about a public charging system for electric vehicles as a packaged solution, we wouldn't, as a first step, ask, how do we need to design the box? How do we need to design the cable and the plugs and so on? We would rather ask, what are the functions? And the functions are to charge electric vehicles, to inform customers, and to access the charger. These are like three basic functions that this system needs to deliver. And any product and service that is actually able to deliver this function can become part of that solution. And then in the next step, we make sure they're interoperable and they are able to work with each other. So based on this functional taxonomy, we are actually able to customize packaged solutions for cities. This is a completely new approach to an urban market, but we are already seeing it is speeding up the way how cities implement smart solutions. So this is a spin-off from the Fraunhofer Society. Feel free to use it. It's open. Everyone can access it and use it. Just on top of that, a few considerations on how to build a smart city, because that was the market side, but we also need to consider the local, the city, the municipal side. And since I don't have that much time left, I will be quick with this, but I still want to mention the main points. So a key issue is to come from a top-down master planning approach to a more integrated, systemic, and agile planning. We built that on a model which is called the Morgenstadt framework, and which basically resembles the steps that you need to take in order to come to an individual smart city implementation or strategy or roadmap. And usually we start to talk about the innovative and clean and connected technologies and infrastructures like I just showed you. But once as a city you want to start implementing this, you realize, well, I actually don't have the means. I don't have the tools, the planning instruments to do that, right? I'm not using BIM. I'm not used to co-creating with my local community. So you need to change the way you plan and, also the instruments that you apply in your city. And once you've done that, you will realize, oh, actually, inside our municipality, we are not used to working across the different departments. If I want to procure a smart lighting system that is able to give light and manage the parking space, does that need to be managed and procured in the energy department or in the mobility department? And who is to fund it? Out of whose budget, out of whose pocket comes the budget, and so on. So this is calling for totally new ways of urban governance and smart city management. So these three levels, the technologies, the tools, methods, and planning approaches, and the governance system need to come together to build an agile and systemic integrated planning of cities. We've applied that to many cities, Prague, Lisbon, Chemnitz, Berlin, Tbilisi, a couple of additional ones, and it shows that this is able to really, if you align the activities on these three levels, you're actually able to increase the speed of innovation in a city. Another point that is crucial is the way how we calculate investments into our cities or urban infrastructures. The traditional way of designing a new district or designing or planning and building a new building is like this. We don't spend money on the idea, and we spend the most of the money during the operation. In order to be successful in your smart city, we need to spend much more money at the front-loading part. We need to be front-loading smart technologies and integrated infrastructures in the ideation and conceptual stage. We're not used to do that. If we're able to do that, we can reduce a tremendous amount of money that we are spending in the operation phase, because we will get much more efficient systems. And at the same time, we're actually able to increase value generation, because if we consider the design at a very early stage, we're able to offer value-added digital services to citizens, local companies in a district. So we need to work on totally different life cycle-based business and financing models. Last but not least, the living lab is the principle that we are using for designing and piloting smart cities. And if you ever happen to try out or wanting to try out a new innovation and technology in a city, the principle of the living lab is definitely something to look into. So with this, I come to an end. Thank you very much for your attention, and have a great day.